Hey everyone!
Welcome back to TecHacks. I'm Lekha.
And I'm Trisha.
And today we're going to be learning about diodes.
So let's get to it. So what is a diode?
So a diode is a semiconductor device that essentially acts as a one-way switch for current. It allows current to flow easily in one direction, but severely restricts current from flowing in the opposite direction. So a diode is a two-terminal electronic component that conducts current primarily in one direction. So diodes are one of the simplest but most useful of all semiconductor devices. Many types of diodes are used for a wide range of electronic applications.
A diode is a specialized electronic component with two electrodes called anode and cathode. The most common function of a diode is to allow an electric current to pass in one direction, called the diode's forward direction, while blocking it in the opposite direction, that is the reverse direction. As such, the diode can be viewed as an electronic version of a check valve.
So how does a diode look? This is a Schottky diode, the most commonly used diode, and this is a Zener diode. We'll be learning about it in the next presentation.
So the symbol of a diode in a circuit, you all know about circuit diagrams, so you need to know what kind of symbol to use in those circuit diagrams. So you use these symbols. The triangle is for the anode, and which is the positive direction, and the line is for cathode, which is negative. In the diode, to identify the positive and negative, the silver is the negative and the black part is the positive.
So types of diodes. Small signal diode. It is a small device with disproportional characteristics and whose applications are mainly involved at high frequency and very low current devices such as radios and televisions. To protect the diode from contamination, it is enveloped with a glass, so it's also named as glass passivated diode, which is extensively used as 1N4148.
Large signal diodes. These diodes have a large PN junction layer, thus the transformation of AC to DC voltages is unbounded. This also increases the current forward flow capacity and reverse blocking voltage. These large signals will disrupt the functional point also. Due to this, it is not suitable for high frequency applications.
Zener diodes. It is a passive element, works under the principle of Zener breakdown. So it is similar to normal diode in forward direction. It also allows current in reverse direction when the applied voltage reaches the breakdown voltage. It is designed to prevent the other semiconductor devices from momentary voltage pulses. It acts as voltage regulators.
Light emitting diode, LED. You guys must be really familiar with this one. These diodes convert the electrical energy into light energy. It undergoes electroluminescence process in which holes and electrons are recombined to produce energy in the form of light in forward bias direction.
Constant current diodes. It is also known as current regulating diode or constant current diode or current limiting diode or diode connected transistor. The function of the diode is regulating the voltage at a particular current.
Schottky diode. It's written as Schottky, but it's German, so yeah. In this type of diode, the junction is formed by contacting the semiconductor material with metal. Due to this, the forward voltage drop is decreased to minimum. The semiconductor material is N-type, that is negative type, silicon, which acts as an anode, and the metal acts as a cathode, whose materials are chromium, platinum, tungsten, and various others.
So laser diodes. You might have seen these very frequently. So similar to LED, in which active region is formed by P-N junction, electrically laser diodes is P-I-N diode, in which the active region is an intrinsic region. Used in fiber optic communications, barcode readers, laser pointers, CD, DVD, Blu-ray reading and recording, and also laser printing. So hope you enjoyed the video.
Like,
share,
subscribe,
and hit the notification bell.
And don't forget to leave a comment. Thank
Bye.
you.